All right, before we get started, I just want to talk a little bit about something that you already learned in one of the previous videos. Remember, all students take calculus. Okay, we are going to need that for this video. And just a reminder, everything is positive in the first quadrant, sine, cosine, and tangent. Sine is the only thing that's positive in the second quadrant. Tangent is the only thing that's positive in the third quadrant. And cosine is the only thing that's positive in the fourth quadrant. Okay, so if you read the question, it tells you that theta is in quadrant 2. So I'm going to draw myself a picture, and I am going to draw an angle that goes into quadrant 2 like that. I'm going to draw my terminal side. Okay, now technically, theta is this angle right here that I just drew. But in reference to what we're going to be doing in this particular question, we usually like to refer to the reference angle, which you just learned in the previous video. And remember, the reference angle is the angle that's formed by the terminal side and the x-axis. So that would be this angle right in here. So even though this technically is theta, sometimes we'll just put a theta in here to help us along with the rest of the question, which will involve this in a second. Okay, so I am going to mark the reference angle in red. So here's the reference angle. And like I said, sometimes we will call this theta. The other thing that we do is from the terminal side, we're going to drop a perpendicular. Okay, and it's always going to go to the x-axis. So in other words, from this point, I'm going to go straight down, and it will be perpendicular to the x-axis. Remember, that means forms a right angle. I'm going to draw that in a second. We never drop a perpendicular to the y-axis. It's always to the x-axis. Okay? All right, so what you're going to do is you're going to draw a line from that big red point that I have here, and you're going to draw a line straight down. Remember, you should be taking notes in your packet. And I said it was a perpendicular, so we've got a right angle there. Okay, so now let's look at this sine theta equals 5 over 13. So remember that the sine is the opposite over the hypotenuse. So that means 5 is the opposite and 13 is the hypotenuse. So what we do is we start at theta in this triangle, and we ask ourselves, where is the side that's opposite theta, which would be this one? And that we're going to mark with a 5. Then we ask ourselves, okay, starting at theta, what's the side that's the hypotenuse of this right triangle? And that would be this diagonal line right here. So we're going to mark that with a 13. Okay? Now you see that you have a right triangle. We have two sides, and we don't have this bottom side right here. I'm going to call it x. So you should know that when you have a right triangle and you want to find a missing side, we can do the Pythagorean theorem. So a squared plus b squared equals c squared, and that'll help us find x. So in any order, you can write 5 squared plus x squared, or you could write x squared plus 5 squared. It doesn't matter. But 13 is the hypotenuse. It's opposite the right angle, so that has to go in for c. So we're going to get 25 plus x squared equals 169. We're going to subtract that 25 over, and that's going to give us 144. And then we're going to take the square root of that, and we get 12. So then we know that this missing side right here is 12. Okay, now let's read what it asks us. So it asks us to find the values of cosine theta and tangent theta. All right, so let's just think of a couple of things that we know about cosine. Well, cosine we know is the adjacent over the hypotenuse, right? And we know that tangent is the opposite over the adjacent, so katoa, right? Okay, so I'm going to start with finding the cosine of theta. Cosine of theta. So it's the adjacent side, so I'm going to go back to this triangle. Here's my theta, my reference angle. And the side that's adjacent to this angle is 12, and the hypotenuse is 13. So I'm going to write 12 over 13. Now, here's where we have to just be a little careful. We just found a value for cosine, and we are in the second quadrant. So this is why I had us review all students take calculus. So my triangle is in the second quadrant here, and the only thing that should be positive in the second quadrant is sine. And I don't have sine here, I have cosine here. So that means that that cosine value should be negative. So there's my answer for the cosine of theta. All right, so I'm going to repeat that again for tan theta. So tan theta equals, now tangent is the opposite, so let me go to the reference angle. Okay, I'm going to go to the opposite, which is 5, over the adjacent, which is 12. So I'm going to write 5 over 12. But I'm going to check again for that positive versus negative thing. So I'm in the second quadrant, and I know the only thing that's positive in the second quadrant is sine. And I don't have sine, I have tangent. So I need to negate that value. So here are my two answers. So let's look at the next question, number 17. It's the same thing, except that they don't tell us what quadrant we're in, but we could figure this out. So let's look at this. So they give us that the tangent is radical 7 over 5. Okay, now that's positive, right? So there's no negative there, so we know that tangent is some positive value. And here it says that the sign is less than 0. Well, a number that's less than 0 is negative, right? So that means that the sign is a negative value. So if we look at this, all students take calculus. What quadrant do we have if the tangent is positive and the sign is negative? And that would be the third quadrant. So I know that my answer, when I'm looking at any answers that I get, I'm going to refer to that third quadrant, and the only thing that should be positive is the tangent value. Okay? All right, so let's look at what they're asking us to find. So we know that I'm in the third quadrant, so I'm going to draw myself a triangle, just like I did in the last one. I'm in the third quadrant. Now technically, that is angle A, right? But we're looking at the reference angle always. So the reference angle, I'm going to shade that, will be this space right in here, because remember the reference angle is the angle that's formed from the terminal side to the x-axis. Okay, then remember we have to make a triangle, but remember that I said to you, you're going to take a point on the terminal side, and we always draw a line perpendicular, but it always goes to the x-axis. So I do not want to go this way because that's not the x-axis. So I'm going to go straight up like that. Okay, so I'm going to draw myself a triangle, and I know that it's a right triangle. All right, so the next thing that I'm going to look at is the value that they gave me. They gave me the tangent was radical 7 over 5. Well, I know tangent is the opposite over the adjacent. Right, so I'm going to go down to this triangle down here. Here's my reference angle in red. The opposite side is here, and that's going to be radical 7. So radical 7. Then I'm going to go back up, and I'm going to look over here, and 5 is the adjacent. So let me go to the reference angle, and the side that's adjacent to this reference angle is this horizontal side right here lying on the x-axis. So that is 5. So I'm going to put a 5 right there. Okay, and just like the last one, I can find the missing side, which in this case is the hypotenuse, if I do the Pythagorean theorem. So I'm going to do 5 squared plus radical 7 squared equals x squared. So that's going to give me 25 plus 7 equals x squared. That's 32 equals x squared. So x is the square root of 32. I'm going to break down that square root of 32. So I know that there's a perfect square in there, and that would be 16 and 2, right? So then x would equal 4 radical 2. So that's my hypotenuse, If you want to call it C instead, that's up to you. All right, so now we need to answer the question, and the first question that they're asking is sine. They want you to find the sine of A. Okay, so I know that sine is the opposite over the hypotenuse. So I'm going to go over to my triangle. I'm going to find that reference angle. The opposite is radical 7. The hypotenuse is 4 radical 2. Okay, so again, the opposite is radical 7, and the hypotenuse is 4 radical 2. Now, there is a rule that states that we can't have a radical in the denominator. So we have to do what we call rationalizing. So the way that we get rid of that radical 2 in the denominator is to multiply by itself. And I'll show you in a minute. So what I do to the bottom, I have to do to the top. All right, so let me explain why this works. So we've got the sine of A equals, okay, well, in the numerator, radical 7 times radical 2 is radical 14. And in the denominator, let me just point here, I've got radical 2 times radical 2. Well, isn't radical 2 times radical 2 just 2 without the radical? Okay, because radical 2 times radical 2 is technically radical 4, and the square root of 4 is 2. Right, so then what I really have here is 4 times 2. So I have rationalized the denominator there by getting rid of the radical in the denominator. Okay, all right, so lastly, let me just kind of simplify that a little bit. So I've got sine A equals the square root, that's an equal sign, sorry, of 14 over 8. Okay, last thing I need to check though is, remember, we have to check the quadrant and figure out whether that value is going to be positive or negative. So I'm in the 1, 2, third quadrant, and I know tangent is the only thing that's positive in the third quadrant. So that means that this value should be a negative radical 14 over 8. Okay, so let's do the same thing with cosine. This is getting a little messy looking, I'm sorry. All right, so cosine of A. Well, cosine up here, I know, is the adjacent over the hypotenuse. So if I go to my right triangle, find my reference angle, the adjacent will be 5, and the hypotenuse will be my x value, which was 4 radical 2. Okay, so then again, my adjacent is 5 over 4 radical 2. I can't have a radical in the denominator, so I'm going to rationalize by multiplying the numerator and the denominator by that radical I'm trying to get rid of. So that's going to give me cosine of A equals 5 radical 2. Okay, I'm going to kind of combine steps here. So I know radical 2 times radical 2 is just a 2, right? Times that 4, which is going to give me 8. Then the last thing I want to check for is, again, I have cosine, but I'm in the third quadrant. And the only thing that's positive in the third quadrant is tangent. So I need to negate that value. So my final answer for the cosine of A will be negative 5 radical 2 over 8. Number 18 tells you that you are in quadrant 2. So I'm going to go straight to drawing myself a picture. Quadrant 2, there's angle X. Remember, we always refer to the reference angle, however. So my reference angle would be right there in red. And remember that we always drop a perpendicular from the terminal side to the x-axis. So in this case, I'll be going down like that, and we've got a right angle. Okay, so they give you the sine value, and we know that sine is the opposite over the hypotenuse. So if I'm looking at my reference angle, which is right here, then I know that my opposite here is 17, and my hypotenuse, which is this diagonal right here, is 21. So let me put that in there. So I've got 17 here, and I've got 21 here. Okay, so I can find this bottom side here, I'll call it B, by doing the Pythagorean theorem. So I've got 17 squared plus b squared equals 21 squared. So that's 289 plus b squared equals 441. I'm going to subtract the 289 over, and that's going to be equal to 152. So b is the square root of 152. And I know that there is a perfect square in that, so that would be 4 and 38. Now remember, if you don't know that, just remember you can take the number 152, go into your y1 and write 152 divided by x, and then go to your table and look for the two factors. That would be 4 and 38. Those multiply to 152, and 4 is the perfect square. So you can do it that way if you don't know off the top of your head. All right, so then this would be b equals 2 radical 38. Okay, so they want you to determine the tangent of x. So tan of x, I know, is equal to, just going to write it right here, the opposite over the adjacent. So I'm going to go back to that triangle. Here's my reference angle. Opposite is 17. The adjacent is b, and we know that that's 2 radical 38. So my opposite is 17, and my adjacent is 2 radical 38. Okay, well, I have a radical in the denominator, and I can't have that, right? So I'm going to rationalize. Now, this is going to look a little messy. I'm sorry, I'm kind of running out of room over here. So I'm supposed to multiply by square root of 38, squeeze that in, and another square root of 38, I'm squeezing that in, sorry about that. And then what that is going to give us is the tangent of x equals, in the numerator, I'm going to get 17 radical 38. And in the denominator, I'm going to get 2 times 38, which is 76. Okay? All right, last thing, but certainly not least. We have to determine whether my value is going to be positive or negative. So remember, all students take calculus. So I'm in the second quadrant. Sine's the only thing that's positive, but we have tangent. So that means we need to negate this value, and that would be your answer. All right, so this one's a neat little question. It's a little bit different. This doesn't really flat out tell you what quadrant you're in, but it does say that the terminal side of angle theta passes through the point -4, 3. Not hard, you can still do this. Okay, so -4, 3 would put us 1, 2, 3, 4, 1, 2, 3. Wouldn't that put us in the second quadrant? So there's your terminal side. Here's your angle. And there's your reference angle right there. Okay, so it's still good. All right, so now remember, we always drop the perpendicular, and it always drops to the x-axis. It always goes to the x-axis. So like that. Okay, now, they didn't give us any fractional value. Like normally they'll tell us, oh, you know, sine x equals 17 over 21, like they did on number 18. Well, they didn't do this in 19. However, we know they gave us this point, and actually, let me go back and label that. This point is -4. Oh my goodness, that doesn't look like a 4. -4, 3. So that means that we know from 0 all the way out here, we're covering a distance of 4. It is in the negative direction, but it's still a length of 4, and we know this distance is a length of 3. So we can simply then just write that this side is 4 and this side is 3, and I'm going to find the hypotenuse. So 3 squared plus 4 squared equals c squared. So that's 9 plus 16 equals c squared. So that's 25 equals c squared. So c is equal to 5. Okay, so what do they want us to find? They want us to find the numerical value of sine. So I'm going to write sine theta equals, well, I know that sine is the opposite over the hypotenuse. So I'm going to go to that triangle. Here's my reference angle, and from here, I'm going to find the side opposite it. So opposite is 3, and the hypotenuse is C, which I know is 5. So that means this will be 3 over 5. Now, let's double check, because we need to determine whether that value is going to be a positive 3 over 5 or a negative 3 over 5. So remember, all students take calculus, and we notice that sine is the trig value that's positive in the second quadrant, and that's exactly what we have. So we are good to go. There's our answer.